Hi everyone, this is Alba from AFSA Education, and in preparation for the upcoming finance midterm, we're releasing 3 Excel tutorial videos on the time value of money in bonds. This is the first video, which covers the topic of present values, and these worksheets will be released with the videos. The only difference from the worksheets is, for the questions I'm going to cover, I've taken the time to set up what I'm going to go over, just for the sake of speed. So let's start with the second question, because when you can get the second question, the first one also comes pretty easily. So it's asking, what is the present value of each cash flow at time 0? And what is the sum of cash flows present values? So, as we know, the present value is equal to the cash flow divided by 1 plus the discount rate. I'm going to freeze the discount rate with F4 because I'm on Windows, but I'm not too sure what it is on Mac. And then all that to the power of the time. Copy and paste that formula. And I'm holding shift down to highlight all of these. Enter. So we've answered the first part of the question. So the present value of each cash flow at time 0 is whatever value here is in the present value row. And what is the sum of the present values? That's not too hard to find out either. We use this Excel sum function. And we highlight all the numbers in this present value row. So to do this, enter. And if you're wondering how I did that, I'm holding down Control to go between the two ends, holding down Shift to select everything. Moving on. Question 3. If the discount rate is 6.26%, what constant cash flow for 10 years gives you a total present value, this total present value? So, to start off, I'm just going to insert an arbitrary cash flow, because it's not as simple as dividing this present value by 10. And then, since I've inserted that, I'm going to copy it into all of these other boxes. And just something to note, this won't work if you type in 20,000 to each of these boxes individually. You actually have to copy it with a formula, because the what if analysis will not work otherwise. And again, let's present value this. So 20,000 divided by 1 plus our discount rate, use the discount rate, to the power of the time. Copy it into everywhere, and we're looking for the total present value. So let's do the sum of our present values as we have now. And as you can see, this doesn't match up with what we have, which makes sense because this was a random number that we started with initially. So how are we going to fix this? Sum of present values. Go Data, What If Analysis, Goal Seek. Set cell, the cell with our present values, to the value that we want. So 188,646 by changing this cell. And since we changed this cell, and these ones are copied with a formula to change with it, everything is going to adjust. So as you can see, this is the cash flow that we were looking for. If you wanted to be specific, and you see how it has 0.6, if you want more decimal places, just add some more decimal places. But we are done with this question. Moving on, question 4. If the discount rate is 7.2% with the following cash flows arriving between years 1 and 5, what cash flow in year 6 results in a total present value of 510,000? So what we're solving for is a missing cash flow in year 6. So I've set up all these numbers. Now let's present value them. Cash flow divided by 1 plus the discount rate. Use the discount rate to the power of the year. And we'll copy this formula into each of the different years, including year 6, even though we don't have a value here right now, because it'll make sense later on. So we sum all of these present values, including year 6 again, since year 6 is included in our total present value. So now we go Data, What If Analysis, and we're going to use Goal Seek again. Set the cell with our sum to what we actually want, so 510,000 by changing this cash flow cell. It works as long as you have the formula in here. If there's no formula here, it's not going to work because these aren't interrelated with each other. Go. And there you have it. That is the value we are looking for. Second last question. What is the timing of a 425,145 cash flow with this present value given a 14.17% discount rate? This question is a little different because now we're solving for time. We're not actually going through a whole series of time. We're actually looking for one specific cash flows, what the timing of that cash flow is. So like we inserted an arbitrary 20,000, I'm just going to insert a random time too. But our cash flow is very specific in that we have 425,145. And our discount rate is also specific. 14.17%. Using these numbers that we have, we're going to find the present value. We go cash flow divided by 1 plus the discount rate. Don't have to freeze it since we're not copying it into any other cells. And as we may have expected, this number does not equal this number because our time is incorrect. Over and over again we use goal seek, so let's do it again for this one. Goal seek. Trying to make this present value equal this present value. 417,624 by changing our time cell. Cool. So it might be a higher time actually on the midterm, but for the purposes of this question, this is the time that we were looking for. Last question. If the cash flows are 877 in the first 7 years and 1642 every year after until year 10, and the total present value is 8923, what is the discount rate? So earlier we solved for timing, now we're solving for discount rate. So set up a present value row. Present value all these numbers, so cash flow divided by, actually, before we do that, let's set up an arbitrary rate. Discount rate. So I like to use 5%. You could use whatever number you want because it's going to change in the end anyways. So cash flow divided by 1 plus discount rate frozen to the power of the time. Copy that into all the other boxes. And we're looking for this total present value. So let's do sum of PVs, sum function, holding control and shift, enter. This is the sum we get, but it doesn't match, right? So let's do our what if analysis. Goal seek to value 8923 by changing our discount rate cell, since this was originally a random number and it's what we're trying to solve for. Okay, and we get this as our discount rate. This is the correct discount rate that we needed. As you can see, our sum of present values is now correct. So, cool. So now we've covered all the questions. There are more questions that I didn't go over just for the sake of time. But again, to review, in question 2, we looked for finding the present value at time 0, looked at the sum function, looked at solving for constant cash flow, looked at solving for a missing cash flow, looked at solving for a time, looked at solving for a time, and looked for solving for a rate. So that concludes the first video. Stay tuned for more on future values and bond problems.